Hello everyone, this is Shrawan Sir, making maths simple for you. Welcome to my YouTube channel, Karna Maths Academy. Today in this video, we are going to discuss one of the most important questions, which is from Principle of Mathematical Induction. Here we go. Dear students, the question is, applying Principle of Mathematical Induction, prove that 2 power n is less than n factorial for n greater than or equal to 4. Dear students, in this question we are given a statement and we have to prove it by using the principle of mathematical induction. Dear students, according to the principle of mathematical induction, in order to prove any given statement, whether it is true or not, whether it is right or wrong, at first we have to prove that the given statement is true for n equals 1. Then we assume that the given statement is true for n equals k, and by assuming that the given statement is true for n equals k, we prove that it is true for n equals k plus 1. And finally, we conclude that the given statement is true for all the natural numbers n belongs to n. So let's find out the solution. So dear students, at first we have to suppose the given statement as Pn. Let Pn be the given statement. Let Pn be the given statement. Therefore, the given statement Pn shows that 2 power n is less than n factorial for n greater than or equal to 4. That means this statement is true for the values of n greater than or equal to 4. That means we are restricted to take the value of n 1, 2, 3. Dear students, so let's show that this given statement is true for n equals 4. When n equals 4, when n is equal to 4, let us put the value of n4 on both sides. This implies 2 power 4 means 2 to the 4, 4 to the 8, 8 to the 16. The value of left hand expression we get 16 less than 4 factorial. 4 factorial means 4 into 3, 4 times 3 times 2 times 1. That means, so 4 is a 12, 12 is a 24. 24. So dear students, on the left hand side we have got 16, the number 16, and on the right hand side we have got the number 24. That means 16 is less than 24. Of course, the number 16 is less than 24. That means we can say that the given statement is true for n greater than or equal to 4. So let's write on the conclusion. So in every step we have to write on the conclusion. It shows that Pn is true for n equals 1. That means we can write P1 is true. It shows that P1. So if we put the value of n1 in our given statement, then it will be P1. So we can say that it shows that P1. The value of n we have taken 4. So we have to say P4, not P1, because here the condition is for n greater than or equal to 4. So we should not be confused. So if we take the value of n4, that means our statement will be p4. So we can write it shows that p4 is true. That means the given statement is true for n equals 4. Dear students, now the second step of the principle of mathematical induction is we have to assume that the given statement is true for any natural number n equals k. So let's assume, let's go to the next step. Let's go to the next step. Let us assume that the given statement is true for any natural number n equals to k, which is greater than or equal to 4. Let's assume that let us assume that or we can write, let us suppose that, let us assume that Pn, that means given statement, is true for n equals k. Let us assume that Pn is let us assume that Pn is true for n equals k, where k is greater than or equal to 4. Where k is greater than or equal to 4. So dear students, let us put the value of n, k in our given statement. Then our statement will be pk. Therefore pk shows that 2 power k is less than n factorial is less than, so we have put value of nk on the left hand side. So on the right hand side also we have to replace n with k. See, if we replace n with k, then the given statement will change in the form of pk such that 2 power k is less than k factorial for k greater than or equal to 4. For k greater than or equal to 4. So let's say this is statement I. So dear students, now by assuming that the given statement is true for n equals k, we are going to prove that this is true for n equals to k plus 1 also. Now we saw that Pn is true for Pn is true for n equals k plus 1. Dear students, so now we are going to put the value of n, k plus 1 in our given statement. Then it will be pk plus 1 such that 2 power k plus 1 is less than n factorial. That means we have to replace n with k plus 1. So dear students, in our given statement Pn, we have put the value of n k plus 1 on left hand side and right hand side both. So dear students, now we are going to prove that this statement is true for k greater than or equal to 4. So dear students, let us prove that this is true for n equals to k plus 1. Dear students, we have to assume here that k plus 1 k plus 1 is greater than or equal to 4, because our statement is given as 2 power n less than n factorial for n greater than or equal to 4. So if we replace with n k plus 1, then it will be k plus 1 greater than or equal to 4. That means we are going to prove this statement is true for n equals to k plus 1 for k plus 1 greater than or equal to 4. So by solving this, we also get k is greater than or equal to 4 minus 1, 3. So this is now we are going to show that this statement is true for k greater than or equals to 3. So now, dear students, in the previous video, if you have not watched the previous video, please watch it, because in the previous video already we have proved three similar types of problems. So you are requested to watch it and you can easily understand all the solutions. Dear students, now in order to prove that the statement is true for n equals k plus 1, we are going to use that the statement is true for n equals k, because already we have supposed that the given statement is true for n equals k. So we are going to use this students, now we are going to use this statement, because already we have assumed that the given statement is true for n equals to k. So by taking this, we are going to prove that it is true for n equals k plus 1 also. So by 1, so let's write down by 1, by I, by I. So let's manage this space. So this means by I, we have 2 power k. We have 2 power k less than k factorial for k greater than or equal to 4. So we are going to use this one and prove this expression is also true. That means true for n k plus 1. So dear students, so we need some manipulations, because we are going to make the expression of left hand side same as the expression of the left hand side of the statement, which we are going to show for n equals k plus 1. So dear students, we are going to change 2 power k in terms of 2 power k plus 1. So dear students, we know that 2 power k plus 1, 2 power k plus 1 we can also write as 2 power k times 2 power 1. See, if we break down the expression of the left hand side, 2 power k plus 1, then we get 2 power k plus means into 2 power 2. So this expression 2 power k we are going to change into 2 power k plus 1. So dear students, we need to multiply by 2 on both sides. So let's copy this expression this side now. 2 power k we have less than k factorial. This implies, so this is, let's multiply by 2 on both sides, so that we'll get 2 power k plus 1. So if you multiply by 2 on both sides of this expression, then 2 power k into 2 less than 2 into k factorial, 2 times k factorial. So this students, so dear students, now if we multiply 2 power k and 2, then we get 2 power k plus 1, because base are same. So according to the multiplication laws of indices, if base are same, then we have to add the powers, or we have to add its indices. Now 2 into 2 times k factorial. So this is, we have got exactly 2 power k plus 1. which is the expression of the left hand side. When we take n value k plus 1, then the expression on the left hand side is 2 power k plus 1. So exactly we have got the same. Now we are going to focus on the expression of the right hand side. So this is, if we look at the expression on the right hand side, we get we need k plus 1 factorial. So this, now we are going to change into k plus 1 factorials. So dear students, in the previous video also we have done some manipulations, some tricks. So what we need, we focus on that. Forget what you have, focus what you need. So dear students, I need k plus 1 factorial. So this keeping 2 as it is, and this k factorial I'm going to change into k plus 1. So coefficient will keep as it is. So k factorial we have to change into k plus 1. So simply I have copied this k plus 1 factorial over here, and let's balance with this. So dear students, I need k plus 1. So I have added plus 1. Now in order to balance, I have to subtract 1 also here. Then only it will be balanced. So dear students, so adding plus 1 and subtracting 1. So plus 1 minus 1 means again we'll get the same. So now it is balanced. So dear students, always what we need, the same thing we copy and then we balance it. Now I need the relation less than. So let's write down less than, relation less than. Then I need k plus 1 factorial. So I'll just copy this one over here, k plus 1 factorial. So let's compare whether it is eligible to write k less than k plus 1 factorial or not. So let's compare k plus 1 factor with 2 times k plus 1 minus 1. So 2 times k plus 1 minus 1 means it is same as 2k factorial. So dear students, if we put the value of k, let's put the value of k. We can put the value of k 3. Let's check whether it is true by putting the value of k 3 or not. We can put the value of k greater than or equal to 3. So if we put the value of k 3, then so we are just checking whether we can write this whole expression less than k plus 1 factorial or not. So we have to check it. So if we put the value of k 3, then k plus 1, the value of k plus 1 factor will be 3 plus 1. If we put the value of k 3, then 3 plus 1 will be 4, 4 factorial. And 4 factorial means 4 times 3 times 4 into 3 into 2 into 1. 4 times 3, 3 times 2, 2 times 1. That means we get 24. The value of k plus 1 factorial is 24 when we take the value of k 3. And let's put the value of k 3 on this expression also, 2k factorial. So dear students, if put the value of k 3, then 2 times of 3 factorial. 3 factorial means 3 into 2 into 1. That means 2 3 is 6, 6 2 is 12. So dear students, the value of this expression is 12 when we put the value of k 3, and the value of this expression we have got 24. So now if we compare the number 12 with 24, we can write 12 less than 24. That means yes, the given statement is true. So now we can write, dear students, now we can say that the given statement is true. So dear students, now we can say that pk plus 1 is true, because exactly we have got the relation 2 power k plus 1 less than 2 power k plus 1 is less than k plus 1 factorial when the value of k is greater than or equal to 4. So dear students, so let's write down the conclusion now. It shows that it shows that pk plus 1 is true. It shows that pk plus 1 is true whenever pk is true. Whenever pk is true. So dear students, at last we have to write on the final conclusion. So dear students, we have proved that the given statement, at first we have proved that the given statement is true for n is greater than or equal to 4. Then we have assumed that the given statement is true for n equals k, and by assuming that the given statement is true for n equals k, we have proved that the given statement is also true for n equals k plus 1. Hence, by the principle of mathematical induction, so the final conclusion is, hence by the principle of mathematical induction, hence by the principle of mathematical induction, Pn is true for all n belongs to n. N means natural number. So dear students, in this way we can conclude that the given statement is true for all the natural numbers n belongs to n. So if you want to take a screenshot of this solution, please, you can take it. So dear students, so almost all the problems related to the inequality, the type of the relation of inequality, we have proved almost all the problems. So already we have solved all the types of questions in the previous videos. So you are requested to watch all the videos. So I hope that you have understood the solution of this problem also. Next time we'll meet with the new content. Till then, bye. Have a nice day. Thank you. Thanks for watching.